Hello. Hello and welcome to this video on Rust exemplified read through. So we are going through the vectors methods. So there is quite a lot remaining. We'll see how many videos it takes. It doesn't matter how many it takes. We'll completely go through it. So we had covered till dedupe and retainment. We were here. Yeah. So we will start with the dedupe by key. So dedupe by key takes two arguments, f and k. So f is a mutable function, okay, which will be most probably a closure. And then k is partial equality, that is, it should support the ordering. Now, suppose what the description says is removes all but the first of conjugative elements in the vector that resolve to the same key. If the vector is sorted, this removes all duplicates. Okay, so suppose vector is 10, 20, 21, 30, 20, and our dedupe by key is you dereference the element and divide by 10. So once you do that, the conjugative duplicates are removed. So you see here 10 is divisible, so it will keep it, 20 will be kept, 30 will be kept, and 20 will be kept again. 21 will not be kept because it is not divisible by 21. So it depends on what closure you pass to it. Accordingly, it will work. Next is dedupe by. So it takes just a mutable closure and it will take one of the elements as well. So it removes all but first of conjugative elements in the vector, satisfying the given equality relation. The same bucket function is passed references to two elements from the vector and must determine if the elements compare equal. The elements are passed in opposite order from their order in the slice. So if same bucket AB returns true, A is removed. If the vector is sorted, this removes all duplicates. So we have foo bar, capital bar, bars, bar. So you see what will happen is it will take two arguments and our condition is that A should be equal to B and we ignore the ASCII case. So this bar will be equal to this bar and then it will be removed. Okay. Push within capacity is time nightly only. Then we have the function pop and it will return an option enum which may contain an element t. Removes the last element from the vector and returns it or none if it is empty. If you would like to pop the first element, consider using vecdq pop front. So if we pop this, it will take the element 3 and return some 3. So when you compare the vec.pop with sum 3, it will be equal. And after that, vector will be 1, 2. Then we have pop if. So it will take a predicate fn once, removes and returns the last element from a vector if the predicate returns true or none if the predicate returns false, or the vector is empty, the predicate will not be called in that case. So here our predicate is that it should be divisible by 2. Now we send this predicate to pop if and 4 is divisible by 2. So when you pop, it will give you sum 4 and then the vector will become 1, 2, 3. After that, if you supply the predicate, A is not divisible by 2, so it will return none. So the predicate percentage x percentage 2 star x percentage 2 means you take the last element and divide by 2. Then we have append. So it takes another vector as well. It moves all the elements of other into self, leaving other empty. Panics if the new capacity exceed I size max bytes. So we have two vectors 1, 2, 3, and then we have another vector 4, 5, 6. We append vector 2 into vec, so it will become 1, 2, 3, 4, 5, 6. and vec2 will become empty. Then we have drain. It takes a range as input and returns a drain object. So R here is range bounds. Okay. Removes the subslash indicated by the given range from the vector, returning a double-ended iterator over the removed subslice. If the iterator is stopped from being fully consumed, it drops the remaining removed elements. The return iterator keeps a mutable borrow on the vector to optimize its implementation. Annex if the range has start bound greater than end bound, or if the range is bounded on either end and past the length of the vector. If the return iterator goes out of scope without being dropped due to mem : forget, for example, the vector may have lost and leaked elements arbitrarily, including elements outside the range. So we have a vector here 1, 2, 3, and we drain starting from 1. Okay, that means 0th index will not be drained. So what essentially that means is 2, 3 will be put inside this U. Okay, so V will be a slice of 1 and U will become a slice of 2, 3. Then if you drain the full range, that is dot dot on V, then it will become empty. Then we have clear, clears the vector, removing all values. Note that this method has no effect on the allocated capacity of the vector. So if a vector is 1, 2, 3 and you invoke clear on it, it will become empty, and is empty will return true. Then we have len, which returns usize, returns the number of elements in the vector, also referred to as its length. So we have vector 1, 2, 3, and len will return 3. Then we have is empty, which returns a bool, returns true if the vector contains no elements. We create a new vector, and then is empty will return true. If we push any elements in the vector, is empty will return false. Then we have split off. It takes one position at and returns a vector. Now A is cloned, so it will be returned by cloning. Splits the collection into 2 at the given index, returns a newly allocated vector containing the elements in the range at comma len. At will be inclusive, length will be exclusive. After the call, the original vector will be left containing elements 0, at. So at is exclusive here and 0 is inclusive, with its previous capacity unchanged. If you want to take ownership of the entire content and capacity of the vector, see memtake or memreplace. If you don't need the return vector at all, see vec_truncate. If you want to take ownership of the arbitrary subslice, or you don't necessarily want to store the removed items in the vector, see vec_drain. It panics if at is greater than length. So we have vector ABC and we are splitting at position 1. So one slice, that vec slice will contain A, and vec2 will contain BC. Okay. Then we have resize with, which receives a new len and a closer. Resize the vec len, not closer. Yeah, it will be a closer. Okay. Resizes the vec in place so that len is equal to new len. If new len is greater than len, the vec is extended by the difference, with each additional slot filled with the result of calling the closer f. The return value from f will end up in the vec in the order they have been generated. If new len is less than len, the vec is simply truncated. This method uses a closure to create new values on every push. If you'd rather clone a given value, use vec resize. If you want to use the default trait to generate values, you can pass default : default as the second argument. It will panic if the new capacity exceeds the max byte, which is the usual case. So we have 1, 2, 3, and now we are resizing with 5, and we are passing it the default. So new vector, the vector will become 1, 2, 3, 0, 0. Then we create another vector. Okay. We have a mutable variable p is equal to 1, and we resize with 4 and for 4 elements, and what we do is we go on multiplying p with 2 and we return 2 in the closer. So 1 will become 2, and then 2 will become 4, and 4 will become 8, and 8 will become 16. So the new vector will be 2, 4, 8, 16. So 4 elements because we needed 4 here. Then we have leak. Okay, consumes and leaks the vec, returning a mutable reference to the elements. Note that the type T must outlive the chosen lifetime A. If the type has only static references or none at all, then this may be chosen to be static. As of Rust 1.57, this method does not reallocate or shrink the vec, so the leaked allocation may include unused capacity that is not part of the return slice. This function is mainly useful for data that lives for the remainder of the program's life. Dropping the return reference will cause a memory leak. So we have a vector and we leak the vector and put it inside a static ref of the size usize. Note the lifetime is static here. And then we add 1 to index 0. So 1 will become 2. So our static ref will be 2 to 3. Then we have spare capacity underscore mut. So returns the remaining spare capacity of vector as a slice of maybe an init t. The return slice can be used to fill the vector with data. The example, by reading from a file before marking the data as initialized using the setlen method. So we create a vector with the capacity 10 and we call spare capacity mut on uninit, and we put in 3 elements 0, 1 at index 0, 1 and 2. The values are 0, 1 and 2. And then in the unsafe we set the length to 3. So our vector will become 0, 1 and 2. Then okay, this is resize function. So it takes new len and value, resizes the vec in place so that len is equal to new len. If new len is greater than len, the vec is extended by the difference with each additional slot filled with value. If new len is less than len, the vec is simply truncated. This method requires T to implement clone, that is this type. In order to be able to clone the past value, you need more flexibility or want to rely on default instead of clone, use vec resize with. If you only need a resize to a smaller size, use vec truncate. Any condition is same that it should not, the capacity should not increase the isize max. So we have vector hello and we resize it to size 3 and we put the type this value as world. So the two new positions index 1 and 2 will contain world. Then we have ABCD, we resize it to 2 and we resize it with underscore, but since there are 2 elements needed, these 2 are dropped. Okay. Then we have extend from slice, clones and appends all elements in a slice to the vec. It traces over the slice other, clones each element and then appends it to vec. The other slice is traversed in order. Note that this function is the same as extend, except that it also works with slice elements that are clone but not copy. If Rust gets specialization, this function may be deprecated. The panic condition is same. We have a vector with element 1 and we extend this vector from the slice to 3, 4. So the result is 1, 2, 3, 4. Then we have extend from within. So it takes an SRC where this is range bound. Given a range SRC, clones slice of elements in that range and appends to the int. SRC must be a range that can be form a valid subslice of the vec. Annex if starting index is greater than end index, if the index is greater than the length of the vector, or if the new capacity exceeds isize max. So we have a vector of characters A, B, C, D, E, and our range which we take starts from 2 onwards. So 0, 1, 2 are same, and then 2 onwards is C, D, E. Okay, from 2 to end. So these many elements are taken and extended. So new stuff is CDE. Then we have 0, 1, 2, 3, 4. So in this case, elements, the range is up to 2. So 2 will be exclusive because the ranges are closed at left side and open at right side. So it will include 0 and 1. and 0 and 1 are included here. Then we have hello world and exclamation mark. Okay, and range is from index 1 to 2. Okay, and 0 will be excluded here. So hello is not copied, world and exclamation mark come twice. Okay, now we see into flattened. Okay, so it takes a vector of type t and then number of elements and flattens it into tn. Okay, panics if the length of a resulting vector would overflow a u size. So here you have to consider this, that it will be a vector of vectors. All right. This is only possible when flattening a vector of arrays of 0 size types, and thus tends to be irrelevant in practice. If size of t is greater than 0, this will never panic. So we have vector of vectors, we pop, we get 7, 8, 9. And if we flatten this, it will contain 1, 2, 3, 4, 5, 6. So when you pop this, it will contain some 6. Then we have dedupe. Removes consecutive repeated elements in the vector according to the partial equal weight implementation. If the vector is sorted, this removes all duplicates. The consecutive elements are 2 here, so one of these will be removed, and then the resulting vector will be 1, 2, 3, 2. Then we have splice. So you see here range R is range bounds and replace with I is into iterator. We have not covered iterators yet, so that is something we will cover next once we finish the standard library documentation. Creates a splicing iterator that replaces the specified range in the vector with the given replace with iterator and yields the removed items. Replaced with does not need to be the same length as range. Range is removed even if the splice iterator is not consumed before it is stopped. It is unspecified how many elements are removed from the vector if splice value is leaked. The input iterator replaced with is only consumed when the splice value is stopped. This is optimal if the tail elements in the vector after range is empty, or replaced with yields fewer or equal elements than range's length, or the lower bound of size underscore hint is exact. Otherwise, a temporary vector is allocated and the tail is moved twice. It panics if range has the same condition start bound greater than end bound, or if the range is bounded on the other end and past the length of the vector. So we have vector v 1, 2, 3, 4, and we create a new one 7, 8, 9, and we splice vector v. Our range is from 1 to 3, so 3 will be excluded, 1 and 2 will be included, and we collect it. So you see that our vector v is here and new is here. Okay, and our range was 7, 8, 9. So 1 to 3, that is 1 to 2 and 3 will be removed from here, and it will be put 7, 8, 9 will be put there. So it will become 1, 7, 8, 9, 4, and our u will become 2, 3 because 2, 3 were removed from this splice operation. Using splice to insert new items into vector efficiently at a specific position indicated by an empty range. So we have this vector 1, 5, and then 2, 3, 4, and then we splice at position 1, 2, 3, 4, and then we have 1, 2, 3, 4, 5 here. So we will stop here, and in the next video we'll continue at extract if. So it's a big one. It will take after next video it will be slightly faster. Okay, and the functions are quite simple. So we'll continue rest of the documentation in the next video, and I hope that you're enjoying this read through and learning more about Rust vector data type, or rather collection, or in C++ terms container. So thanks a lot for watching the video, and we will meet again after 4 days on with the fourth part on the vectors. So I wish you all the very best in your Rust endeavor. Thanks a lot again for watching the video. We will meet again on the fourth day. Thank you. Bye.